Okay, so we are just plotting the points from tangent if you're going around the unit circle. So we plotted 0, and then you can't divide by 0, so we had undefined, another 0, undefined, another 0. So now we're going to figure out what's happening in between the 0 and our asymptotes. So we know that at our pi over 4s, which are our halfway points, we have root 2 over 2. This is going to get sloppy. And root 2 over 2. And when you do sine over cosine, or y over x, and the two numbers are the exact same, what's our tangent going to be? What's root 2 over 2 divided by root 2 over 2? That's going to be 1, right? So at pi over 4, which is halfway between 0 and pi over 2, so the halfway point, our y value is at 1. Now we'll check our next halfway point. We've got negative root 2 over 2 and root 2 over 2. When you divide these two, what number are you going to get? Negative 1. Good. So our next halfway point is at negative 1. We'll go to our next halfway, our next pi over 4. They're both negative in this quadrant. A negative divided by a negative makes a positive. So the next halfway point is back at positive 1. Are we kind of seeing a pattern? So our next halfway point would be at negative. The next one would be at positive 1. And this is what your tangent graph actually looks like. So it starts down at the bottom next to your asymptote. It curves up and goes here, and it's broken up into these sections. And it repeats.
Why wouldn't it start at that 0 point?
I'm going to do that one in a second. I just didn't have a line drawn over here. I'm going to do this asymptote at negative pi over 2. And here are the points for this one. This one would be at negative 1, and there's an asymptote right here. There you go. Wish there was a setting that I could make the pen the thin pen instead of the thick one, and I didn't have to hit that every time. All right, so that is what our tangent graph looks like. It's a series of these curves that start down and end up. Okay. The difference between tangent and sine and cosine is what the period is. So for sine and cosine, it takes you from 0 to 2 pi before your graph starts to repeat again. Okay. So if I'm at 0, this is if I say 0 is my beginning point, that's where I started the graph. I'm going up, I have an asymptote, I go up, I'm back to 0, and then I start the exact same thing again. Up, asymptote, up, 0, up, asymptote, up, 0. So how long did it take for me to get back to my starting point where I repeated my process again? I'd go from 0 to pi. Do you see how it starts over again at pi? That I'm just repeating this section each time. Up, asymptote, up to 0. Up, asymptote, up to 0. So instead of our period being 2 pi, like in sine or cosine, in tangent, it's just 1 pi. So your values repeat after you get to pi. It's the exact same thing over and over and over again. Okay, so that's the difference with tangent and also cotangent than we had with sine and cosine. So our period is just a regular pi. So if you have any kind of transformation of your period, if you have a b value, instead of doing 2 pi over b, for tangent and cotangent, we're just going to do pi over b, okay? If you have a change in your period for tangent and cotangent, we do pi over b instead of 2 pi. That's a main mistake that I see on this test is people forget that with those two specific trig functions, you're not using 2 pi, you're just using a single pi. All right, are y'all ready to graph cotangent? What do you think cotangent is going to look like if you had a guess?
The opposite.
It's going to be the opposite. So what kind of opposite do you mean?
Like that in the like that first half in the middle is gonna be -1 maybe.
First half in the middle would be negative pi. This one here would be a -1.
Yes, like you know how the arrows are going this way? They're just
Go the other way. Well, let's see. This will be fun. So I grouped those. I need to copy it. I want to make sure I can see this again. Okay. So we're doing cotangent. Cotangent instead of y over x is x over y. Or cosine over sine. I'm going to make tiny marks for my pi over 4s because we'll need to have those on there. Okay. So we're doing y over x this time instead of x over y. So if I'm at 0 degrees, what did I say? We have to do x over y, not y over x. I don't know. I think I said it backwards. So we're doing the x on the top, the y on the bottom. So we have 1 over 0 for 0 degrees. Can you divide by 0? Nope. So at 0 degrees is where we will find our first asymptote. I have to draw it next to it because won't show up if I put it on top of that black line. All right, now I'll go to pi over 4. Those were both the same, root 2 over 2 over root 2 over 2. I don't know why it disappeared here. So at pi over 4, it's going to be the same as tangent, and that will be a positive 1. 0 divided by 1 for my pi over 2, 0 over 1 is going to be what? 0 divided by 1 is 0. Good. For my 3 pi over 4, or this halfway point, I've got x over y, negative over a positive of the same number, so that's going to be a -1. Then when I get to pi, I have -1 over 0. Can we divide by 0? Nope. So what are we going to have? Asymptote. Okay, and at this point, I already told you that pi is going to be the period. So starting now, we repeat and we do it again. So 1, 0, -1, asymptote. Same thing if we go backwards. I just don't really want to do the backwards today. So just like a tangent, the period is pi rather than 2 pi. Transformations are the exact same besides the period as we had before. If you had a number added at the end, it would shift the whole thing up and down. If something was in the parentheses, that's going left or right. A number in the front, we don't call it amplitude because there's not like a minimum and a max, so it's not doing that. But a number in the front is going to change the ones. Like if I had a 5 in the front of here, instead of being at 1 and -1, these two numbers would be at 5 and -5. So it just makes it a little bit steeper there. Okay. Everything else changes the same way. Shifts left, right, up, down. as we did before. All right, are we ready for secant and cosecant? Here we go. Or like, even if I'm not ready, she's going to do it anyway, so I might as well just nod my head. And with that, you would be correct. Like, there's some things in math that are just like kind of cool, like, oh, that's kind of neat how that worked. But the graphs of cosecant and secant, I think, are like amazing. Like, how cool is it that they are going to end up the way that they look? And you'll see why. I think it's just fabulous. Are you on the edge of your seat? I thought so. I thought you were like, oh man, this is going to be great. We don't need these, but I'll fill it in anyway. Okay. So cosecant is what flipped over? Sine. It's sine flipped over. So once you know what sine is, flip it, and you're going to get your cosecant value. Okay? So we're going to do the same thing. We're going to do the quadrants. I don't think that we need the 45s in this. I think we're just going pi over 2s. So we're going to look at our y values, and we're going to flip them over. So at 0 degrees, what is your y value? What's the y value at 0 degrees? It is 0 at 0 degrees. And remember, this is what 0 looks like if you were writing it as a fraction, because you would put a 1 underneath it. So if I were to flip that over, if I flipped it to get cosecant, so flip it, you'd have a 0 on the bottom. And can we have a 0 on the bottom, Alan? No, we can't. So what does that mean in our graphs? No 0 on the bottom equals asymptote. So at 0 degrees, we got asymptote. Can't have a 0 on the bottom. Now we're going to pi over 2. I'm going to flip 1 over. 1 is 1 over 1. So when you flip it over, isn't it exactly the same? Okay, so at pi over 2, I'm at 1. Now I go to pi. The y value was 0. Can you flip 0 over and get an actual number? Nope. So what are we going to have? Asymptote at pi. 3 pi over 2. Oh no, my number left. This was 0, -1. We've got -1 for the y. -1 over 1. When you flip it over, you still get -1, right? Okay, so at 3 pi over 2, I'm at -1. Back to 2 pi, I will have an asymptote. At this point, we start to repeat. So it takes from 0 to 2 pi for us to finish our graph.
So that's the period.
Yeah, the period's 2 pi for these. Because that one was up and that one was down, so we'll have to, so the period is 2 pi for cosecant and secant. And here we go. This is what the graph actually looks like. All right. We are flipping over our numbers that we got for sine. And our numbers for sine go from 0 to 1. And so when you flip fractions over, just in case you didn't know, like if I flipped over a half, you would get what? 2. If I flipped over a third, I would get 3. So none of my numbers are going to be underneath 1 because I'm flipping those fractions over from 0 to 1. And this is how it looks. Are you ready? Are you sure? No one has shown any kind of emotion. This is our cosecant graph. It comes down, it hits that point, goes back up on the asymptote. They're in these little U-shaped sections. This one comes up to the 1, -1 I mean, goes back down on the asymptote. Now I'm going to show you guys, and then it keeps going. So it's like an up U, down U, up U, down U in that repeated pattern. And this is why I think this graph is so cool, because cosecant is sine flipped over, right? I'm going to draw the sine graph on this just so you can see and see why it's so neat. So sine starts at 0, ends at 0. This is what sine looks like. Y'all agree in here? And it's an up and then a down. Okay, so this is sine. I'm going to do dotted line. We just said cosecant was sine flipped over. What happens when you flip this over? You get that. If you flip this over, you get this part. So each of those sections, if you flip them, you're going to get the cosecant graph. So if you can draw, I always draw the sine graph first. I don't go through all this stuff with the points. I go, oh, cosecant, I'm going to do sine. Where there was a 0, I put an asymptote, and I flip the other ones over. So once you know what the sine looks like, you can just place it on there and then flip, flip. So let's do the secant graph, but we'll do it in this method rather than getting our points. So secant is cosine flipped over. So I'm just going to sketch a cosine graph, put zeros on my asymptotes, and then flip it. So I'm going to lightly sketch my cosine. So cosine starts at 1, ends at 1, in the middle at -1. These are my zeros, right? Dots. That's what cosine looks like. That's one period of cosine. So if I'm going to make one period of secant, are my asymptotes going to be at my whole pies or my half pies? Remember, asymptotes happen when the original one was 0, because you can't flip a 0 over. So our asymptotes in this case are going to be at the half pies. So my actual secant graph I'm going to do in blue. So I'm going to flip this section over. It'll look here. It would finish on the other side as well. Here and here. It does keep going. So secant and cosecant are just shifted over pi over 2 from each other, just like sine and cosine were. Its period is 2 pi. It takes from here to here to start repeating. Okay. The difference is where the asymptotes are. Asymptotes are on whole pies for cosecant, half pies for secant. It corresponds to zeros from sine and cosine. We're going to do one with a number in the front just so you can see how that changes the graph. But then after that, I'll write down what all the transformations could be, and then you can work. Hey, Jalea.
Hey. Oh, I'm sorry.
That's okay. So we're going to graph 4 cosecant theta. I'm just going to show you how you can quickly graph it just by using the sign. So all I'm going to do, just like I did with that cosine or that secant graph, is I'm going to draw 4 sine theta and then flip it. Okay? So we're going to all draw 4 sine theta and then flip. Our asymptotes go where the zeros are. And we flip. We don't ever go underneath where that highest point would be on the sine graph. It's always going to be our minimum in that case, and this lowest point is going to be our maximum for that u over there. So a number in the front of your graph like that is going to change your highest and lowest point of your cosecant and secant.
So what was the max minimum? Apologies.
The maximum in this section, there's not like a global one because it goes up forever and down forever. But if you're looking for local ones, like right here, of the minimum of this u is 4, the maximum of this one is -4.
Okay,
but if they ask like what's the max and min for the whole graph, there's not one because it goes up and down forever and ever. Okay. But there won't be, the graph will not exist in the section where sine or cosine, depending on if it's secant or cosecant, would have been drawn. So if you can think about how would it look, how would it shift just normally, just get it to where it should be and then just flip the sections over. Are y'all glad you don't have to draw these by hand? Mm-hmm. All right, so just a reminder with transformations, you don't really need it, but I'll write it down just in case. Let's see. It's the same thing we did last time. A number in the front, that's our vertical stretch, which was called amplitude. Now it's just a vertical stretch. The B value is going to be our horizontal stretch or compress, which will give us our period. And for cotangent or tangent, it's just pi over b. For secant or cosecant, it's 2 pi, just like the cosine and sine. This in here is left and right. Plus is left, right is minus. This is up or down. So the only thing new in terms of transformation is just that for tangent and cotangent, it's pi over b instead of 2 pi. And that's all.